Nemish and Shreyash, you both of them removed from the lab, join with the Marwari Education mail ID. Both of you, Nemish and Shreyash. Nandini and Bhavisha, remove from the lab and join with the Marwari Education mail ID. Because with this Google Chrome, I have add-ons to take the attendance automatically. Okay, so I don't want to be joined with a different mail ID. Those who are joined, if the attendance will be present in my add-ons, then and only then I will consider. Otherwise, I will not consider. So better you just leave and join with the Marwari Education mail ID. then it should not ask me to add you in this link. Okay, from our lab, which is the last experiments we had completed, all of you. Abhishek, Durga, pretty completed about did we completed seventh completed. Eighth is remain no seventh is completed. All the labs Abhishek seven is completed. The branching operation, the push and pop, everything is completed. The remaining is eight. We had not completed for code conversion. Do we completed that how to convert your hexadecimal number, hexadecimal number into BCD and BCD to hexa? Okay, so we'll complete that thing today. Okay, so experiment number 8. Let me open the experiment date and present in front of you. Okay, so let me present what is the experiment we have. Is the screen is visible, all of you? Is the screen is visible, all of you? Okay. So in this experiment, we need to complete this task. So we need to write a program which can able to convert hexa, the corresponding here instead of ASCII, write BCD number. Okay, so in the BCD number, first program, second write a program to find the square using the lookup table. Now I'll tell you that what do you mean by the lookup table. Write a program to calculate the factorial of a number from 0 to 5. You know about the factorial, okay? So this task I will leave upon you, and these two tasks will be completed by today. Okay, fine. So now let me present one screen in front of you where I'll teach you the concept of lookup table and the code conversion technique. Now let's start with this experiment 8. Okay. What is the do you mean by like a BCD number? All of you? What do you mean by the BCD number? That is already you completed and you will studied. Yeah, binary plus 0101. That is, I agree with you. So till 9 or till 10, the binary and the BCD numbers remain same. Used for only single digit. How many bits? For a single digit, how many bits we need to use? Let's suppose consider 12. How will you write BCD and how will you write binary for 12? Okay, very good. So for each digit, we have a 4 binary numbers, correct? Very good. Just a minute. Okay, and that is not the BCD number we have. So in this, let's suppose consider for example 138, or let's suppose 338. So how will you write this 338 into BCD? You know the very well. First we write a 4 digit. First we wrote a 4 digit for this 3, like a 0011. For this 0011. For this one 000. This is how you will write the BCD, correct? That means if I had given an any hexadecimal number, let's suppose this is the number I had been given. What I need to do the first task, separate out the each digit. Separate out each digit and store it to the memory location. Let's suppose 6001, 6002. So copy this here, 03. Copy this here, 03 and 08. This is how we need to separate out the each and every terminology. Each and every digit. So while storing into the memory, this will be stored as a 00000011. Here also it will be stored as 00000011. Because total 8 bit can able to accommodate in a one memory location. Okay, so it's like this one. And here it will be a 00001000. Here, this is our task to do, but how to do that is important. Again, let's suppose take a 338. 338. Okay, so 3 subtract 100, you will get a 228. Again, the 100, it's 128. Those who had completed, you can those lab sessions might be one lab session is combined today. I think so is not feeling that good. So those who had completed this experiment go on uploading on an canvas, because today for the two labs which I had teach for them, I will close the deadline, and the one lab is remaining. I will be opening for that. Okay. So if you have completed, so you can go on this. And there is one more experiment we had uploaded, that is experiment number 9, and that is totally depends upon the Booth algorithm, and that is we had completed in the lecture also. So you can go that and complete the 9th experiment, upload it. Okay, till experiment 7 is there. I'll upload and wait just a minute, I'll upload an experiment 8. Okay, so I had uploaded the tools. Now no one is allowed to be present in the lab session. Okay, many requests I am getting, but I may not allowing anyone. You can drop a message in a group that now no one is allowed to join this lab. So if you subtract this, we are here. So if you subtract again minus 100, the number is 20. It's a 38. Okay, so 38 means like 100, 100 and 100. Now the number remaining 38 is already less than 100. So how many times you have done the subtraction? How many times you have done the subtraction? 3 times. So I from a 338, I got this first digit. Now the remaining is 38. So how many times you need to do the subtraction? So do the subtraction now because it's the 10th digit, do the subtraction using 10th. So 28, 10, 18, 10, 8. So how many times again I had done the subtraction? 3 times. So I got a second digit also. And the last remaining, that is an 8th digit. So for to store this 100th digit and 10th digit, I must require a one register. What I'm doing? Initially, I'm putting this register as a D as a 0, 0. So when I do the subtraction, I'll go on incrementing this. One time done, second time done, third time done. So D will be 3. Again, same as E register, I'll put 0, 0. That is a 10th digit. How many times I'm doing the subtraction, I'll go on incrementing. So finally, the value of E is 0, 3. Again, the remaining last digit directly is in accumulator. You can directly store it to the any location, a 0, 8. Concept is clear, all of you? The concept is clear. then Harshit, if you don't subtract it, how will you get a digits? We need to separate out each digit, and that's why I'm doing subtraction. Do you have another way? Do you have another way to convert any hexadecimal number into a BCG number? Yes, Harshit. Do you have another way to do that? And it should also be compatible with writing a program. Okay, that is why we are doing the subtraction. So how will you write a code? That is what the important concepts here. So this is what I'll present the flowchart in front of you. Think at least something to be done. So this is a step, what exactly you need to do. And this I'm giving you the flowchart. Might be some of the students of the batch already completed, but still those who are new, please try to give the answer. Like how can start a program? Okay, the divide means subtraction. First thing is, it is very much clear. Let's suppose 6,000 location. I have data 138. Okay, let us assume this is data. So first thing I'll always do like LDA is 6,000H. That means the data which is present on that location will be in the accumulator. What is the next thing I need to do? What is the next thing I need to do? I need two data. That is a 100 and I must need a 10. Correct? So I'll use two register to store the data. Okay, like MBI. Let us take B as a 64H. 64 means in a decimal it is 100. MVI C comma 0AH, that is 10. I need two more registers to store the data. So for that I'll write MVI D comma 00H, MVI E comma 00H. So any one will handle the 100 digit and any one will handle the 10th digit of the number. Now you just tell me, let's suppose consider if your number 38 goes below 100, less than 100. So which flag will affect or which flag will set to tell you that the number is already less than 100. I'll do that. Does anyone got an answer? Which flag will be? How many types of flags we have total? In general, how many flags we have? Just in general, how many flags we have? We have a parity flag. Am I audible, all of you? We have parity flag, we have carry flag. Which is the next? Yes, waiting for your answer. Am I audible, all of you? Hello? Abhishek, alive, Ankit, Avinash. Am I audible, all of you? Okay, so which are the flags we have in the processor 8085? And if the number goes below 100, which flag will be affected? Yes, Cable wrote the carry flag. See, when you subtract the number less than 100, you must get and borrow. Then and only then you can able to. So there is no borrow flag, and that is the reason we can able to get a carry flag. Right. So I need a concept uh, where you must require a branching to be done. Yes, the borrow flag will not set, the carry flag will only set. So I must require a branching operations to be done. And that means if the carry flag comes, if the carry flag comes and if carry flag doesn't comes, I need to switch it to the a different location. At what condition, jump with carry or jump with not carry, I need to jump for a, let's suppose I'm going on subtracting the number from 100 and carry flag comes, should I need to do again subtraction or directly I need to go the subtraction from 10? What do you think? If the carry flag sets, then you should go to the directly subtracting 10 number or again you need to do the subtractions using 100. What do you think? What do you think? What should be answer? Subtract by 10. Very good. Okay. So that is what we need to do, and that is what we need to understand. So now I have this thing. So because it might also possible that the number what we are sending that should always be less than 100 also. So what is the next thing I need to do? First I need to compare. I already took the data as in where? In the accumulator. In accumulator I have the data 138. But it might be possible it's not 138, 38. So directly after comparing I just need to go to the subtraction of 10. I don't have to subtract with 100. So I'll write say compare B. That means A will be compared with B and the carry flag will set. So if A is greater than B, carry flag will be 0. If A less than B, the carry flag will be set to 1. So now here I'll check this. For this, the carry flag will not be checked. So I just want to write if the carry flag comes, I'll go directly to the next or directly go to the step 2. For that, I am writing the label as a S2. But what if it is carry flag is not set? Then what you need to do? You need to do the subtract B. That means the data what you already have on 138 and B is 100. So 138 minus 100. So it's a 38. So that is why I had done the subtraction. And whenever you do the subtraction, we had seen you need to increment any of this register. Let's suppose if I'll increment D register. So I write INR D. So one times I had done the subtraction. And directly I'll JMP S1. Where should I write S1 in the program? One time you had done the subtraction, you had incremented D, again you need to do the subtraction. But where exactly this S1 should go? This is an S2. Okay, where should exactly the S1 will go? Where should exactly the S1 will go again? If it is after incrementing this, I need to jump to S1. Where should I write S1 from here? In this branch, where should I write S1? Again, compare it with B. Very good. Okay, so I'll write with the S1 here. Very good. Okay. Now complete the program. The same thing you need to write for 10 and then same need to. You should have the answer in a 6,000, sorry. You should have your answer in 7,000, 7,001 and 7,002. Here it should be a last digit. In this location you must have the 10th digit, and in this location you must have the 100th digit. Let's complete your program. Yes, for you, just I'm presenting the code, and if you have any doubt in that code, let me know. So removing all these things, and this is the code what we have. It's very easy code. Here you need to add just an what is in LDA 6000H. The data is already there in this location. So have a look on this code, and still if you have a doubt at any line that you didn't understand, please let me know. And side by side, you can, if it is possible, write it down in the paper also. So that at last you just need to scan and upload the PDF for an experiment number 8. The numbers are different, that's all. Once you clear, just write it down the yes or no in the chat box so that I can go to the next, the lookup table concept. Done all of you? Should I go to the next now? Is it clear? Okay. So now the next thing, you already know that how to convert this number into a decimal. Let's suppose if I'll ask you another number to convert this 34, which is already in the hexadecimal number. If I want to convert again into, sorry, let's suppose consider 34 is one hexadecimal number, or consider it's a BCD number. Don't write it H. Let's suppose 34 is a BCD number. If I'll ask you again to convert into an hexa number, what is the procedure you will do? First, you have a 34. So we need to separate these two numbers. Okay, so how you can able to do that? You can do the ending operation with a zero, sorry, F0. First do the end operation with a ending operation with a F0. So what happens? What should be the answer if we do the ending operation and A and D? You know about this, the logic operation. When you do the end operation, what is the answer? 38 ending operation, 34 ending operation with the F0. What is the answer? What will be the answer? It's very simple. Waiting for your answer. Zero A, Keval. Look at the presentation. We have 34 is a number. If you do the ending operation with F0, what will be the answer? How it will be the 0A, ending operation? Should I do binary number? So let's suppose 0, 0, 1, 1, 0, 1, 0, 0. Do the ending operation now this. What should be the answer you will get? Now this one is yes, 30. Okay, so I'll just remove this now. It remains with the 30. Now what exactly I need to do? This 30. But this 3, I need one single digit. Okay, only 3. So what I need to do? I need to rotate 4 times. When I rotate 4 times, this number will convert into 0, 3. And you know, this is a 34. So 3 is a 10th digit of the number. So what you can do, multiply 0, 3 with a 10, you will get 30 plus this 4. You will get in 34. But this thing should be happens in hexadecimal number, remember. So to get it in the hexadecimal number, multiply 0, 3 with a 0A. You will get answer as a 1E plus you will add 4. The answer will be 22H. So this is the BCD number and this is an hexadecimal number. Is the concept is clear, all of you? Is the concept is clear, all of you? Yes or no? Either yes or no. Now, how you write a program for that? That is important. What is the approach you'll do? Okay, first try to think, write down a few instructions, whatever you know in the chat box, so that you can start writing a program, all of you. Okay. Okay, sorry, just I got a call in between, so I just disconnected. Uh, so this is what actually we need to do, and this is a program. So first take the data, do the ending operation. Let's suppose 34 will do the FAB. Okay, so this time we are rotating 4 times. So this is the data which we need to. Multiplication is not possible. We don't have any instruction to direct multiply. We have only instruction to. Am I audible, all of you? Because hello, hello.
Yes, sir.
Okay. So multiplication, there is no instructions to do the multiplications. What I need to do, add 10 3 times or 3 10 times. Anyway, you can do it. So what I'm doing here, this 10, 0a is a 10. Okay, 0a is a 10. We need to multiply it. Now, once you do the addition, let's suppose a. What is the data in the a? The data a is nothing but a 0 3. Again, add a 0 3 to that number. How many times you need to do the addition? 10 times. That is a decrement B. So we are go on adding. And if it is not 0, I'll go back again here to do the same process. Till this, the number, this number gets 0. Because every time when you do the addition, you are trying to decrement this. So this will be 9, 8 times 0, 7, 0, 6. Once it will be a 0, 0, it will go outside the loop and it will store the data what we have in the accumulator. That means once you do the multiplication, you will get a 1e, and 1e that will be stored in a B register. Now again, take the same data what you had told in the multiplication process, and multiply it with the addition. So any doubt in this program, let me know. Okay, so this was like a second experiment. Second, we have it not audible properly now or previously, Abhishek? Is it now or previously? Okay, so let me tell you this again. So I hope that till this addition everyone is clear till this step. Like you are doing the addition is till this everyone is clear, I think. Okay. Now for what we had done this thing. Now this process you had done for 34 and for this 3 only you had done this process. What about the 4? We need to do it again. So what I'm doing again, I'm calling the same data 34 from that locations where we had called this here. Now instead of doing F0, now I'll do the 0F. So what happens if I'll do the ending operation with 0F? The answer will be 04. And that will be added with a 1E that is already we got when we multiply 0A3 into got an answer 1E. So now you will get an answer. Once you do the addition, you will get an answer to 22, and that is what we need. So this is nothing but a simple a BCD to decimal conversion. Clear all of you? Is it clear? So write it down in your book somewhere. This problem statements that will be useful for writing in the experiment or during the exam also. So write it down. Once you do complete, let me know. Done all of you? Should I go to the next concept to be used as in the lookup table? Should I complete that? Yes or no? Hello? Hello? Okay, so now let's go to the lookup table. Before explaining the seven segments, you know this thing might be heard seen many times anywhere in this the content day-to-day applications. We had seen this kind of a seven segment. Can anyone say what the DP stands for? For what the DP stands for in seven segment? Hello? Hello? I don't know, the network is too messy. They continuously disconnecting. I don't know why. Yes, where we are. Yeah, I just asked the questions about the seven segment. What the DP stands for? Anyone can write down the fast and the answer before again the network disconnects. Or what? It's a decimal point. Okay. That means whenever you want to display 1.2, there should be a 2 7 segment, and in between you must always have a decimal points. Like you can watch in the digital clock what you have in your home. Okay, that is what the Rashid did with the decimal point. Okay, so there are two types. One is a common anode and one common cathode. In a common anode, this LED, these are the LEDs, not a P and out. In a one lab, I had asked, what is that? He or she told that this is the P and out. No, this is not P and out. This is an simple the LED. Okay, so what we have, this is a positive of the LED are connected to the VCC and the common cathode. The negative terminal of an LEDs are connected to the ground. So to turn any of this LED, let's suppose consider the common cathode to display one on that number, the B and C should be on, rest of them should be disabled. So what I'll do, for the B and C, I'll put 1 and 1, rest of them are 0. Yeah, sorry. Okay, now it is visible. Okay, so this one I talk about the common anode and common cathode. So what we have the common anode. This is an LED. LED positive terminals are connected to the VCC, all the positive terminals. In the common cathode, all the negative terminals are connected to the ground. Let's suppose if I want to display a number 1 on a 7 segment, so B and C should be on and rest of them should be off. So to put it, the B and C should be on, this to be 1 and 1, rest of them are 0. With the opposite process over here, let's suppose B and C, again I need to put it, this is on, rest of them are off. Though one of the point is connected to VCC, this should be connected to the ground to make it on. So this should be 0, 0 and rest of them should be 1, 1. Okay, this is what the difference, the common anode and the common cathode. Okay, now look at over here. It is mentioned the common anode, common cathode. This one is the common cathode. Let's suppose the output, if I want to display 0, what should be the value? All should be 1. All should be 1 except Z, otherwise it will be 8. Okay, so what I need G should be off, rest of them are on. Same way, look at 8. All the LEDs are on to display 8. So we need to display 0 to 9. Okay, so what I'm talking about the lookup table is important. So this is what the lookup table. If I'll give an example of a lookup table, consider you have a table of 5. And if I'll ask you what is the value of 5 into 5, you said 25. How you found that? From step by step, if I'll ask you, let's suppose the input is I need to find, you have one table of 5, fifth table, 5 on the 5, 5 to the 10, 5 to the 15 till 5 10 the 50. If I'll ask you what is the value of 5 into 7, so what you'll do? You will go to the lookup table, 5 into 7, you will memorize the things like what is the answer, and then you will tell me, okay, this is your answer. Correct? Yes or no? Same with the lookup table, also the same thing. Let's suppose, consider in an example, this is a memory address where I had stored some value, and that is nothing but a hexacode. Let's suppose to display 0, 6, the hexa value is 0, 6. Let's suppose to display 2, the hexa value is 5, 8. To display 3, the hexa value is 4F. That means, see, this one is for just an example, okay? This one is for understanding only. In a lookup table, what we have, you have an address and you have the hex code of a number to be displayed from 1 to 8. And this number should not be there. Okay. So what you'll do, let's suppose consider 6000, 6001, 6002, 6003. I have 7000, 7001, 7002, and 7003. On this, I have the data 08, 04, 03, 02. This I want to display it on a 7 segment. But for that, what should be the hexadecimal value? So what you'll do, 08, you will find the hexadecimal value of 08 from the lookup table. What is the value for the 08? Tell me. Just waiting for your answer. What should be the value of hex code for 08? Very good. Someone got the answer. Once you have a 08, from the lookup table, find the hex code and put it here, 7F, and that will be displayed on this 7 segment. So that is the importance of a lookup table. You don't have to convert it any number into an hexadecimal. It directly converts automatically. Okay, using the lookup table. That is what the importance. Okay. So how will approach to the problem first of all? What is the one thing to be observed over here? Look at this. What is the common in each address? What is the common in each address? 62 is common in each address. So what I'll do, I'll take a one, let me take a different pen. Let me take a different pen. HL. In H, I will always fix 62 as an address. Now, what is the number I need to find? I'll copy that number to the L. So directly it redirects to that number, directly it redirects to that address only, and I can easily find the hex code which is stored on that location. Let's suppose take another number. Let us take another number.
From the 6001, I'll copy this number 04. I'll put it into L. So what happens? Total address is 6204. I'll go to this location. I'll copy this data and I'll put it here. And I'll display on a 7 segment. Are you getting the things or not? Is the thing is clear? Importance of a lookup table. So the values are already predefined, stored. Thing is clear or not? Should I explain it again? What is that? At least reply something. So should I move forward? That is what I'm asking. Should I go to the next slide or what you are looking? Is it clear? Fine. So can you able to write a question the program statements for me? Please at least try for 5 minutes, okay? Okay, this was a program. So what we have, I told you in HNL, we store this data. From here, we need to take the data and after finding in the lookup table, you need to store the data into 7000H. So let us take the first data from a 6000H. We always write LDX. So D plus E, 60 and 00, what might be the data that will go to the accumulator. Okay, that is what we call LDAX. Take the first data, copy the data to the L. And what this M stands for, everyone? What the M stands for? What the M stands for? What the M stands for? We used to write it, not in memory block, the memory register. Okay, the combining H and L, it makes a one register. Okay, so M means combination of H and L. So what we have in the H and L now, 62 is a common, and what might be the data on this that will be loaded here. So we'll go to that location, copy that location content, and put it into the accumulator. Then again store to the STXB. Now STX stands for storing the data. B means 7000. So BC is a 70 and 00. So converted data for which is found from here 6D, that will be stored here. Okay. Now after reading and writing the data into this location, I need to move to the 6001 and 7001. Okay, so that is why I just incremented. Now this data, how much data you have, that will be C indicating with the counter. If 5 data, because I written over here the 5 numbers from memory location 6000. So I'll compare it with the C. C will be like 0, 0, 0, 1, 0, 2, 0, 3, and 0, 4. When it reaches to the 5, it will go outside the loop, otherwise it will go back again and then rotate the loop.
Okay. So that was an easy problem statement. Like using the lookup table, you can write anything. So now your task, same way using the 7 segment I had explained you, the same way you need to do it with a memory, what you call square. So you have a lookup table for a square 1 to 5. If I'll give any number in between 1 to 5, you should find the square of that number and should display. No algorithms, no calculations, nothing, just a lookup table only. That is already predefined. Okay? Try it by yourself, at least write some program.
Which are the two batches today? Jatin sir, which has which lab today? A or C? Today my lab is A batch. Which is the batch of Jatin sir? C batch. Okay. So might be tomorrow also we have the lab, the C batch, and we need to do the same thing. So I hope the C batch students complete this task by tomorrow, okay, and upload it on the canvas because the deadline is for tomorrow only. I'm not going to extend the date. So there was one question you need to write, that is nothing but a finding the square using the same, and the next thing is to find the factorial. Now that you have to think and write a program. One task is for you. I hope everyone knows how to do and find the factorial. 3 factorial means 1 into 2 into 3. The same. So let us complete the topic here. I hope you will upload the things in the next class. Now write it down the attendance in a sequence, all of you. And once you write, you can leave. Go in the sequence. Again, I'm telling. Don't write in between A and B, A and C.
Sir,
Yes.
sir, my roll number is 21.
So should I begin to write? Parthiv, I'll not open that thing. That is an assignment. You need to complete it on time. 2 hours, I think 1 hour is enough to do the task.